Hello, everybody. I'm Beniamino Pozzan. I'm a senior robotics engineer at Archangel Autonomy, but also ROS maintainer for the PX4 project. My background is in control system engineering, but in the last few years, I've been working on GPS and ID navigation. So if you're doing something similar to that, also come speak to me, even if it has nothing to do with ROS, okay? The outline for this presentation is about Micro XRCE-DDS and how it interacts with ROS2, how it enables PX4 to talk straight to ROS2, and how you can describe the communication, like how you can configure the client, and when everything's working, how to troubleshoot what happens next. So normally this is message versions, QoS, and synchronization. What I'm not going to talk about is what you can do with ROS2 and PX4, because there have been other talks, very interesting, yesterday, and others, a few more that are following now. I'm just going to give you how you can enable those features to be used. Okay. Yeah. Then, therefore, you don't have actually to see the video, and I'm going to just skip forward. What is XRCE-DDS? Let's start from there. It's a client-agent interaction that brings fast DDS, a Proxima fast DDS, into extreme resource constrained devices like the flight controller unit where PX4 is running. There is no ROS here, so fast DDS is just a possible middleware for ROS2. So, but it's also the default middleware for ROS2. So we coded the client such that everything that is published on DDS is also in the right format so that PX4 can read it. No, not PX4, ROS can read it. And the client runs as a PX4 module, the UXRC-DDS client, while the agent has to run in your companion computer, which can be Raspberry Pi, NVIDIA Jetson, PC where your SITL is running. As long as they are connected to serial or UDP, you're good to go. And then I will talk a bit more about how little control you have over these communications, which makes you responsible for not breaking up. As I said, when ROS2 is using FastDDS middleware, all that you want to make them, all PX4 UOB topics are available as ROS2 topics in the same format they were into PX4. So do not expect to have PX4 IMU data appearing as a ROS2 sensor message IMU topic. No. It's going to appear as IMU topic of PX4, so you have to take care of that. Once the communication is established, ROS2 will be able to publish messages that are going straight into PX4, and at the same time, we'll be able to subscribe from PX4 topics and just do whatever you want with them. The main star of the interface is the Micro XRCE-DDS client module running on PX4. It is responsible for establishing the publisher and the subscribers, and also one service. Who knows that we have one service available, one service server available in the UXRC-DDS interface? Nice, thank you. So that lets you send vehicle command without having to actually publish on the vehicle command topic and wait for the reply on the vehicle command acknowledge topic. Just send a ROS service call. It also manages the time synchronization for you, and also the system clock synchronization, meaning that you don't have GPS, you don't have Mablin connection, but you still want your log file be tagged with the right time. Well, if your PC has a system clock, like a synchronized clock and whatever, RTC, then you can actually forward it to PX4. You cannot do the other way around, though. Not yet, at least. The agent runs on the companion computer. It connects to PX4 through serial or UDP. It supports multiple clients, either multi-serial and also just UDP, one agent, multiple clients connecting to it. As very useful for running multi-vehicle simulation, of course. However, because we are running on FastDDS and is not ROS2, all the features that the interface implements are only the native DDS feature, none of the specific ROS2 one. So, for example, don't ask for parameters. You know, you ask for parameters, most of you, but there is no way to just say ROS2 param set PX4, I don't know, you pick one. This is something that we'll have to work on. So yep, that's one thing about that. But if you're interested, just reach to me and let's talk about that. As I said before, there is minimal control over the communication link. On top of it, and the first consequence of this is, first of all, ROS2 nodes that you register and they start interacting with PX4, because they are publishing at the end of the pipeline your topic directly inside PX4, they have the same capabilities of actual internal PX4 modules. Example, if you try to send a vehicle, Mavlink vehicle command and you do a force arm, so you go and if you dig into the commander, there is a code for forcing arm, the same when you do vehicle arm -F on the NUTX shell, it will be rejected because it's being considered as coming from an external model, so you cannot externally force arm. Yes, you can do that because it doesn't even know that it's coming from ROS2. It has no idea it's coming from ROS2. So be careful about that. So there are no external checks whatsoever. There are also no link saturation checks. So if you're, in particular, if you're working with serial and you set your serial baud rate too low, because I will show you later how much is the bandwidth required for the default set of publisher, you will encounter issues. The client will probably crash and you have very bad surprises. Also, there is no concept of the lazy publisher. So the client is not aware of how many subscribers there are of its published topic on the ROS2 side. Therefore, all of them are just published. And if you are tuning your system for performances and latency, and you are not using all of the messages that are in the default version of the system of PX4, it's better to just remove them, recompile, and flash. About modifying, recompiling, and flash, let's go on and see actually how you do that. So there is one file, one YAML file, a DDS topic file, that lists all the topics that PX4 either listen to or publish to towards ROS. Right now, in our latest stable release, there are 24 publishers that are going a bit less than 70 kilobytes per second. Therefore, the baud rate, for example, for serial, the 921.600, and I remember the name, is good enough for that, but don't try to run it at 50. Don't try to run it less than that, please. Multi-instance publishers are not supported yet. So if you want to, I don't know, log all 3 IMU topics that are inside your PX4 module in ROS, well, you cannot do that. You can only log the first one. But if you're interested in that feature, speak up later. It also implements the DDS topics 27 subscribers. Normally, they all publish on instance 0, but if you want, you can have them publishing in a new instance with the subscription multi feature. In 1.16, the maximum frequency you can publish towards ROS2 is 100 Hz, blocked by the XRCE default poll rate. If you want to go above that, you have to change that parameter, recompile, and flash split.
In 1.17 instead, there have been a few changes, definitely an increased number of subscribers. Those are not critical, because I mean, if you're not publishing to those topics, that's fine. 3 more publishers, but also an addition of a per topic rate limiter that also brought down the standard communication link consumption. You can just tune it regarding to your preferences. We also finally fixed a naming mismatch. Now those old YORC default poll rate is called the YORC default poll interval millisecond, which it always been the number of milliseconds between intervals, so people could get a bit confused in its value. Before going into the client configuration, let me talk a bit about the agent build and version, because things can get a bit messy and confusing here. You have 2 ways to build your agent. One is standalone, just build. The other is inside a ROS workspace. I highly suggest you to do it to the former. You already have your ROS workspace in your companion computer. You just add the Micro XRCE agent to it, and you call build it. It will be much faster than to have it to do standalone, because it will reuse all the dependency, in particular FastDDS and FastCDR, the serializer. But you need to be careful on the version in doing that, because if the version will mismatch with the one installed in ROS, it will fail. So for Foxy, you want to use Foxy and Humble, you want to use 2.4.2. For Jazzy, you want to use 2.4.3. Kilden and Rolling, because they updated to FastDDS 3, you need to compile it standalone. The agent and the client are that is running on PX4 are both the so-called version 2. There is also a version 3 that pairs more nicely with FastDDS 3. The client has not been updated yet, therefore you cannot use agent versus version 3. Absolutely not. They just won't connect, but you can still work untested between agent version 2, so current PX4, and Kilden and Rolling, which are running on DDS3. Be also careful when you try to build it standalone. The version 2.4.2 is broken. So when the dependencies are found, it's all fine. But when it don't find the dependency and tries to build it, then literally Eposima forgot to tag one of their dependencies, so it won't find them and it will fail. In that case, if you're building from standalone, just use always 2.4.3, please. Good reason to build standalone? Well, if you don't have ROS2 in your host, for example, you can have a Raspberry that is only the agent and all the ROS stuff is happening on a different computer, and they are just connected to Ethernet. Or because you can do that if you're just writing pure DDS application and you just don't care about ROS. And yeah, be prepared to very long compilation times. Yes, I mentioned Foxy. Please don't use Foxy. Upgrade. It's end of life. So, but you have to. Okay, it's still supported. The documentation of PX4 supports it. Still mention it. So we'll keep using it. Okay, let's talk about a bit of establishing communication and configuration. I'm assuming now all of you know how to build your agent, and you can. Well, now you know how to start it. First of all, the XRCE-DDS has a few parameters. Probably you just need to use the configuration one. The configuration parameter is literally like Marvin configuration parameter. You pick the serial port or telemetry port or Ethernet reboot, and you're good to go. You also have the domain ID. The domain ID is the equivalent of the ROS domain ID. So if you are using multiple ROS networks, you want them to keep isolated, you have to go modify that parameter. The key parameter is just an internal Micro XRCE feature. Every participant, aka every client, needs to have a different key if it is connected to the same agent. So for single vehicle,
Okay, you keep it to 1 and you're happy. If you are going to multi-vehicle simulation or weird approaches, you have to remember to modify it. But on multi-vehicle simulation, actually that is taken care automatically by the startup script. So you actually have to, you can really forget about that parameter. Then we have these 2 parameters for Ethernet connection. The agent can technically work in discovery mode, or better, the agent can technically work in the client in discovery mode, but we don't use that. So you need to actually tell the client where the agent is listening. So you have to specify the IP and the port. Because PX4 doesn't support string parameters, we have to encode the IP as an int32 variable. But there is a nice tool in the PX4 code base to do the conversion very easy. So you add your IP, then it will split out the actual value that you want to use it. More advanced parameters are the participant or client configurator. For currently, it has only 3 values. The default one, and most of you only use that one. But you can also set it to localhost if you don't want anything to be actually broadcasted after or outside the host of where the agent is running. There is a third value which is external. Okay, there is a third value which actually tells the agent, please go and look for a configuration file that is in the agent side, so in the host, if you want to have like a full customized solution of the participant. We can then turn on and off the timestamp synchronizer. I'll talk about that more later, or the system time synchronizer. You have 2 parameters to set timeout watchdogs. If nothing is being transmitted or received, you can actually basically reboot the client. And finally, in 1.17 alpha, have been added in namespace index parameter, because which lets you, without having to manually start up through the startup files of PX4, the client, and it lets you add a namespace. So if you are doing swarming, that's a very useful feature. It will just add on your ROS2 topics like UAV underscore and then whatever value you put on that parameter namespace. It's disabled by default with the -1 though. Okay. So you know how to configure PX4. Let's not PX4, the client, of course. Let's see how you actually can start it. First of all, you need to have it installed in your system. Okay, normally the client is enabled by default and built into PX4 in most of the boards, and you can just check it to see if the parameters exist. If it doesn't, if they don't exist, then you can just locate your board configuration file, add this to it, recompile, and then start dealing with the flash overflow, because it was not there before. It's probably because it was overflowing the flash. So decide what you want to remove and remove that. Okay, assuming that you have the client and you want to start it. Okay, so let's see how you can start it in serial connection. Just wire them up. Don't use telemetry radios. I told you before, the baud rate is not very low, so it requires quite some baud rate, and therefore don't try to use it over like those telemetry radio used for Q-ground control, for example. Okay, pick a suitable baud rate, start the agent in serial mode, specify the port, specify the baud rate, start the agent. Normally you can just do it from the parameters and verify the connection. Yep. Okay, one very quick way to check if the connection was established is just to look at the log of the agent. It will show the participant connection and then list all the publisher and subscriber in a pretty confusing way. So if no message appears or errors appear, then first thing to do, check your wires, because TX and RX are always swapped. Then check it twice, because the first time you do it wrong. Check that the baud rate is correct, and if those are okay, then let's start checking if your serial port is free on the PX4 side, because maybe you forgot that you had a Mavlink instance on like off-board mode running on Telem2, and then you also try to start the XRCE-DDS client on Telem2. Things don't work well. On the agent side, then instead you can check about the serial port permissions. Maybe you don't have the permission and you cannot just start it. If all of them checks out and you still cannot connect, well, give it a try with Mavlink. Just turn off the client, start Mavlink on the same serial port, and then you can use Mavlink router, Mavlink server now to check if messages are being received on the agent side. If it's still not working, write on the forum or in Discord. Or for UDP is very, very similar. So wire them up via direct connection to a switch, to a router. Configure PX4 Ethernet. We have extensive documentation on how to do that. Starts the agent again, just agent UDP4 and the port where it's listening to. Start the client. So it's first set it to Ethernet mode, then you reboot it. You'll now be able to modify from you can control the IP and the port. You modify that and you reboot again, and then you verify the connection. Troubleshooting in this case is very simple. You try to ping those. Can PX4 ping the agent? Can the agent host ping PX4? Make sure that the port are matching, make sure the IP are matching, check that your firewall is not interfering, and if again doesn't work, try Mavlink. Doesn't work again, reach out. We want you to reach out and say, oh, it's not working or it's behaving weirdly, guys, okay? You can always check if the client is working properly on the PX4 side, just open Natex shell and type XRCE-DDS client status. Will tell you if it's connected, if it's not connected, if it's expecting to work on serial or UDP, and give you a bit of debug information about like cycle time or how much stuff is flowing in and out of it. Okay. Special mention is SITL. In SITL, the client starts automatically on localhost and automatically handles multi-vehicle simulation. So most of the time, you have to do absolutely nothing but to start the agent on port 8888. You can customize the namespace, and it nicely handles multi-vehicle simulation. Let's say that again. If for some reason the agent is not going to connect on the same host, on same IP of the client, like you're doing some Dockerized testing, then you can just modify the startup script or just use, we have an environmental variable you can set before starting PX4 to change the IP for the agent, okay? Okay, at this point, you should have the client and the agent nicely talking to each other, and you are ready to actually do some raw stuff on top of that. So how do you actually now interact with ROS2? So the most important part is that ROS2 nodes needs to know the message definition for your PX4 messages in order to properly deserialize and serialize them. Those message definitions are contained in the PX4/PX4_message repo. How is that repo keeping sync with all the changes of PX4 messages, and what happens if for some reason it goes out of sync? What will you see if that happens? So CI/CD constantly keep it in sync. So every change on PX4 message definition in main will be copied over the main branch of PX4 message repo. For the release branches and tags, we do it manually instead. If for some reason they are not in sync, or you did some modification of one core message, then you will just see a bunch of RTPS errors because the deserialization or the serialization was not successful. There are tools, there is documentation and tools to help you keep them in sync. So please check them out in the documentation of the DDS interface. Okay. I just want to briefly mention that there is a package that is currently hosted inside PX4 repo, and then there is documentation to how to actually export it in your ROS2 workspace that lets you handle message transition. So I don't know if you notice, some messages of PX4 are now called the version messages. They're like core PX4 messages. If you build your application of ROS2 using those messages, and you want to ship the application around, and you don't want to have to think about, oh, what will happen in 6 months if that message will change. Well, if that message was a version message, then through the message transition node, you just put that node in the middle, and you have to follow a bit of instruction, but the automatic transition between newer and older version of the message will be performed. So check it out. Second issue, DDS quality of services. So in ROS2 you can have multiple quality of services, and the same applies for DDS. Unfortunately, the publisher side of PX4 is not using one of the ROS default QoS. So it's using transient local for durability and best effort for reliability. So which is not the standard ROS2, it's not even the sensor QoS of ROS2. You can check them out if you're curious. The only important thing to keep in mind is if you want to subscribe to a PX4 message from ROS2 node, you have to use best effort reliability on your ROS2 nodes. Otherwise, you will have that error over there. Let's say, okay, they don't match. I won't subscribe to anything, and we'll stay just. We'll have nothing to do, left to do. Timestamp synchronization. Timestamp synchronization is quite important because PX4 runs on its own clock. It is normally initialized when the board boots, but ROS2 has a completely different clock. You normally want them to be synchronized and keep it in sync. So this is done automatically by timestamp synchronization feature. It will replace PX4 message timestamp and timestamp sample if that message has it with the correct version. So if it's going towards ROS, it will synchronize it with the ROS. We'll put the proper ROS timestamp version. If it's going into PX4, it will put the PX4 one. The synchronization system estimates the latency of the connection and the offset. So you can actually use it to check how much time does it takes to, no, not the latency, sorry, the round trip type. How much time actually it takes to go from one side to the other. Do you always want the timestamp synchronization? No. There is one special case. If you're running simulation, Gazebo simulation with ROS2, and ROS2 is interactive with Gazebo, then best practices want you to synchronize ROS2 clock to Gazebo, because the real-time factor might not be 1. So normally you start the ROS-GZ bridge, you bridge the clock, so now ROS2 clock is in sync with Gazebo, and then all your nice ROS2 nodes will have to use some time equal to true. So ROS2 nodes are in sync with Gazebo. PX4 is always in sync with Gazebo because that is how the simulation works. So you don't need anymore a timestamp synchronizer between PX4 and ROS2. Actually, it can be I won't say harmful, but could have unexpected results because the agent is, again, ROS2 agnostic. It cannot synchronize the client with the Gazebo, with the ROS clock. It synchronizes it with the system clock. So as long as your simulation is running with like real-time factor equal to 1, you're good. But the moment it starts running even slower or faster, then basically you will keep having warnings about timestamp synchronization out of sync and trying to resynchronize them because maybe your simulation is running half real-time factor and it doesn't add up anymore. So consider switching it off when you're in this scenario. I just want now to conclude with Zeno. So all of this presentation was about Micro XRCE-DDS. So fast DDS as a ROS middleware, but ROS is moving more and more and embracing Zeno. Zeno was already available in PX4 experimentally in 1.16. But now in 1.17 alpha, it's fully supported and documented to work nicely with Xeno RWM for ROS. Again, it's using Xeno Pico, which is basically the equivalent of Micro XRCE-DDS, but for Xeno. And currently, it's only support TCP. So contribution are welcome if you wanted to SIGL, of course. Please try it out, reach out, tell us how it's going, okay? Yes, conclusion, we're running out of time, so you know what I talk about until now. Micro XRCE-DDS, and again, Micro XRCE-DDS, and how to troubleshoot it. Thank you very much, and I'm really happy to answer your question.
We're running 5 minutes behind, so we have 3 more minutes for questions only. Anyone have any questions? Oh, no questions. Everyone's using the DS bridge, I guess. Here you go.
They are all using Mavlink.
Or using Mavlink. Off-board mode.
Off-board mode in line.
This might not be an entirely relevant question, but I feel like you might have the answer to this, so I'm going to ask it. How is the timestamp sample calculated in the... You can also point me to documentation and I can go take a look.
No, the XRCE-DDS interface has native features for timestamp synchronization. So basically, on the client side, we make a request to the agent to do timestamp synchronization. Then it pings back the response, and then we have a custom callback in the XRCE-DDS client that actually do the offset estimation and latency estimation. We save the offset in a member variable, and then every time new subscriber on publisher needs to publish, it's just apply the offset.
And the timestamp sample should ideally be low, right? Like
timestamp sample
to like make sure the timesync synchronization is like working properly. Should the timestamp
the timestamp sample, it's just timestamp sample. Would you mean the latency is going to be low?
Yeah, maybe I can come to you and talk to you about a specific problem I've had with that. But yeah, I just wanted to clarify. Thank you.
It's all good.
Thank you. All right, any more questions? Anyone else? All right, well, if you're using PX4 and ROS, please find Ben. Tell him what you're building. And thank you, Ben.